In this video, let us look at the transformation, which is rotation of axis. For example, let us have the original coordinate system small x, small y, and O is the origin. Now, without changing the origin, let us rotate the axis through an angle of theta. So this theta is a given angle. Now, if you have point P whose original coordinates are x comma y, small x, small y, then let the new coordinates with respect to the new coordinate system be equal to capital X, capital Y. Now the question is, how is capital X, capital Y related to small x, small y? Let me write the answer first and let me try to derive this. So those are interested only in the answer part, you can just remember the answer that we are writing and skip the derivation. So the transformation is something like this: capital X, capital Y is equal to small x cos theta plus small y sin theta. Capital Y is equal to minus x sin theta plus y cos theta. So this is the formulas for the new coordinates in terms of old coordinates. Now, the old coordinates in terms of new coordinates is nothing but capital X cos theta minus capital Y sin theta, capital X sin theta plus capital Y cos theta. These are the formulas to get back the original coordinates from the new coordinates. So let us also see how to remember these formulae. But for that, let us go to the derivation. First, to do the derivation, first let us join the origin with the point and let the distance of the point P from O be denoted by R. And we know that R is equal to root of x square plus y square, which I'll be substituting if required at later stages. So let this length be R. And let us consider that this ray OP makes an angle of phi with the original axis. This ray OP is making an angle of phi with the original axis. So if it makes an angle of phi with the original axis, it obviously makes an angle of phi minus theta with the new axis. So now let us write the equations. So using the concepts of polar coordinates that you have studied, can I write small x as r cos phi, r cos phi, right? Because this ray is making an angle of phi with the original axis. So small x is equal to r cos phi, small y is equal to r sin phi. These are the expressions for the original coordinates in terms of r and phi. Next, if you take the new coordinate system, in the new coordinate system also, because the origin is not changed, the distance of the point P from origin is again equal to r. But the difference is the angle that this ray makes with the x-axis. So this time, can I write capital X is equal to the new coordinate of the point P, the capital X is equal to r times cos of phi minus theta. Cos of phi minus theta. And capital Y is equal to r times sine of phi minus theta. Now once you have these four equations, you have the derivation with you by using the compound angle formulas in trigonometry. That is equal to r times cos phi cos theta plus sin phi sin theta. This is equal to r times sin phi cos theta minus cos phi sin theta. that is equal to, so now r cos phi is x, so r times cos phi is x, so small x cos theta plus r sin phi is nothing but small y, so small y sin theta. Capital Y is equal to, you can see r sin phi as y, r sin phi is y, and r cos phi is nothing but small x. So this becomes minus x sin theta plus r sin phi is small y, so small y cos theta. So we effectively got the derivation for capital X and capital Y. So capital X is equal to cos theta times x plus sin theta times y, and capital Y is equal to minus x sin theta plus y cos theta. So if you solve this by considering this as a linear equation, we can get small x and small y also in terms of capital X and capital Y. So I want you to do the derivation for small x and small y. So once you do the derivation, you get small x small y is equal to capital X cos theta minus capital Y sin theta, and small y is equal to capital X sin theta plus capital Y cos theta. So these are the formulas for capital X, capital Y and small x, small y. Now, before going forward, let us try to see how to remember these results carefully.